Hi everyone, in this video we are going to be learning about the different properties of squares. So a square is a type of quadrilateral. If you are following the inclusive definition of trapezoids and parallelograms, then it is a type of trapezoid, it is a type of parallelogram, rectangle, and rhombus. So basically what that means is a square inherits all of the properties that those shapes have. So for instance, it inherits the parallelogram property that opposite sides are parallel, or it inherits the rectangle property that the consecutive sides are perpendicular and form right angles. It inherits the rhombus property that all sides are congruent. So a square does not have any unique properties. It just combines the properties of the other quadrilaterals. All right, let's look at some sample questions based upon that. Number 1, true or false, the diagonals of a square are congruent. That is definitely going to be true. That's true in a rectangle as well. So since a square is a type of rectangle, it's true here too. Number 2, explain why the parallelogram property, opposite angles are congruent, is true in a square. Well, let's take a look at a square and a pair of opposite angles. We can see here that they're both 90. So the reason that this is true is the opposite angles, and really in a square, all of the angles, the opposite angles are both 90 degrees, so they are congruent. So this is an example of how it inherits that parallelogram property. We can see their opposite angles, 90 and 90, and also congruent. Okay, number 3, in square ABCD, BD is equal to 8, and we want to find the length of AE. Well, in a parallelogram, the diagonals bisect each other. So if BD is 8, that means that it is split 4 and 4. And since the diagonals of a square are congruent, we already talked about that, diagonal AC is also going to be 8 and split 4 and 4. So that means that AE, the piece we're looking for here, has a length of 4. Number 4, find all missing angles in the square below. Well, we have another right angle up in the top right. Those are opposite angles. Now we know that these are right angles too that I'm filling in here. But since there is a diagonal drawn, the diagonals bisect the angles, and each of those smaller angles becomes 45 degrees. Number 5, if each side of a square measures 5 centimeters, what is the length of the square's diagonal in simplest radical form? All right, let's take a look at what that looks like in a diagram. So I have a square, each side is 5, and we want to find the length of one of the diagonals. So I'm going to draw one in here. And what we're basically looking for, I'm just going to highlight so you can see here, is we're basically looking for the length of the hypotenuse of a right triangle. The diagonal of a square is just the hypotenuse of a right triangle. So I can use Pythagorean theorem, 5 squared plus 5 squared equals c squared, c being our hypotenuse. 25 and 25, and I'm going to combine here to get 50, and I'm going to get radical 50 is equal to c. Now this problem does ask us to do simplest radical form, so we want to think about, is there a perfect square that goes into 50? There is. 25, and 2 would be the missing factor. And when we simplify that, we are going to get 5 radical 2 as our hypotenuse. Number 6, determine the measure of angle DBC in the square below. We talked about this a little bit in one of the previous problems too, but we know that these are 90-degree angles in the corner. Angle DBC then must be 45 because in a rhombus, the diagonals bisect the angles, and a square is a type of rhombus. Number 7, if AE is 6x plus 7, I'm going to label that as I read it, and EC is 8x minus 3, we want to find the length of DB. So we talked about before that in a parallelogram, the diagonals bisect one another, which means that it's split into 2 equal or congruent parts. So that tells me that AE and EC have to be equal to one another. So I'm going to set 6x plus 7 equal to 8x minus 3. and I'm going to solve for x. I'm starting by getting the variables on the same side of the equation and getting the constants on the other side. When I divide by 2, I get that x is equal to 5. Now, this problem doesn't ask us to solve for x. It says to find the length of dB, so we just have a little bit more to do. So we're going to have to do some plugging in. So if I want to find the length of, let's say, AE, remember that was 6x plus 7. So if I plug 5 into that, 6 times 5 plus 7 is 37. So I know this is 37. And these were equal, so this is 37 as well, EC. Now, since the diagonals of a square are congruent, DE and EB are each going to be 37 too. Okay, all 4 of these little pieces are going to be of equal measure. So if we're looking for the length of DB, notice that as the whole entire diagonal there, it's 37 plus 37, or it has a length of 74. Okay, number 8, in squared JKLM. JK is 8x plus 2, MJ is 12x minus 8. Solve for x and then find the square's area. All right, well, let's take a look at a picture here. When you are drawing a quadrilateral yourself, does not matter where you put the first point, the first vertice there. So I'm just going to put J in the top left, but we want to just make sure we go in a circular manner going around. So K should not be across the shape diagonally like this. It should be going in a circle, whether it's clockwise or counterclockwise, that doesn't matter. So something like this. So JK is 8x plus 2. MJ is 12x minus 8. And we're just basically looking at 2 sides of a square here, and we know that sides of a square are equal. So I'm going to start by setting those 2 pieces equal to each other. I'm going to get the variables on the same side. Again, kind of just solving our multi-step equation here by trying to isolate our variable. So I have 10 is equal to 4x. When I divide by 4, x comes out to be 2.5. So let's find, we answered the first part of the question, but let's find what one side of the square is equal to. If I find, let's say, JM, I'm going to use my calculator over here. If I plug in 2.5, 12 times 2.5 minus 8, that tells me that one side of the square, I'll fill this in here, is 22. If I plugged 8 into JK, 8 times 2.5 plus 2, you'll see I get the same answer, so it doesn't matter which one we plug into. So to find the area of a square, it's going to be length times width or base times height. So the area is 22 times 22. So the area of this square is 484, and then we'll just say units squared. All right, for our last problem, something a little bit different. It says quadrilateral ABCD has these vertices. We need to prove that the quadrilateral is a square. So I'm going to start by plotting my 4 points. I'm going to move my calculator out of the way just to give us a little more room here. So even if these problems say that graphing is optional, I would definitely recommend that you plot. I think it helps you understand a little bit better what we're looking at. All right, so once I have my 4 points plotted and labeled, make sure you put the letters next to those points. I'm going to go ahead and connect those, and it should look like a square. If it doesn't, check your points again, make sure you plotted correctly. We definitely want this to look like a square and match the shape that the problem is giving us. So in order for this shape to be a square, we have to think about, is there a formula that we could use? And there's multiple, but is there a way we could prove this is a square besides just saying it looks like one? So the way I like to do a coordinate proof with a square is to use the distance formula 6 times. So the 6 times are going to be for the 4 sides, so AB, BC, CD, and DA. Those are the four sides of the square. We want to make sure they're all equal to one another because all the sides of a square are equal. But in a square, the diagonals are also equal to each other. So I'm going to do two more distance calculations for AC and BD. And I'm going to make sure those diagonals are equal. All right, so using the distance formula, it's the big radical, the change in x values over the squared, plus the change in y values squared. All right, so for AB, when I'm looking at the change in x values, that's like -1 minus -6, for instance. So 5 and 1, and this comes out to be radical 26. Now, if I did that correctly, the next three answers should also come out to be radical 26. So we want to use that to kind of like self-check our work here. All right, BC, I get 1 squared plus -5 squared. That negative is not going to make a difference because we're squaring it, and that comes out to radical 26 as well. Okay, for CD, I have -5 and -1, so radical 26. And to get that 26, I'm just doing -5 squared plus -1 squared. Make sure you have parentheses around that if you're typing that into your calculator. And then for DA, -1 squared and +5 squared gives me radical 26. So all four sides are equal. That is not enough to show it's a square because that could be a rhombus. That's why we're doing these extra two calculations for the diagonals to prove the diagonals are also congruent to each other. So for AC, the change in x values is 6. The change in y values is -4. So this is going to give me 6 squared, or 36, plus 16 and radical 52. Okay, we're going to do the same thing for BD. The change in x values is going to be -4. The change in y values is -6. And that gives me radical 52. Just so you know, if for when you're finding that number inside the parentheses, if you have a positive where I have a negative or vice versa, that is okay. That just means you're subtracting the points in a different order than me, and we'll get the same answer in the end. So not a big deal at all. All right, let's write a conclusion of how we know that this is a square. So I'm going to say that ABCD is a square because all four sides are congruent and the diagonals are congruent. We want to make sure we add that extra piece in about the diagonals. Okay, while there are different ways to complete this coordinate proof, this is just the way that I prefer to do it, using the distance formula repeatedly to prove things are congruent to one another. Hopefully this lesson helped you understand a little bit more about the properties of squares and how squares really just inherit the traits of the other quadrilaterals, as mentioned before. And you can check out the other videos in this playlist if you need more help with other quadrilaterals. Thanks for watching.